we learned how to solve oblique triangles in all 4 possible cases of what could be given to you. And then 2 of them will require for you to begin using the law of sines, and 2 of them will require by you using the law of cosine. So now we can do that. We can do some of people's favorite thing, which is applications. So we are going to do, let me see how many examples I have. I have 5 different examples. So let's begin with number 1. 2 ships leave port at 4 p.m. One is headed at a bearing of northwest 38 degrees and is traveling at 10 miles per hour. The other is traveling 12 miles per hour at a bearing of southwest 47 degrees. How far apart are they when dinner is served at 6 p.m.? Okay, so they leave the same port. And anytime you have a bearing, you want to draw a compass. So north, east, west, south. So the first one is going northwest. So I'm actually going to move this over to have some space for it to go northwest. So it's going northwest 38 degrees. So this direction. And the bearing always goes to the north-south line. So this is my bearing right here, and this is 38 degrees. The other is going southwest, so it's going somewhere here. And I believe he's going a little faster because the first one is going at 10 miles an hour and he's going at 12. So my bearing here is going to the south line at 47 degrees. So they leave port at 4 p.m. We want to know how far apart they are at 6 p.m. So 2 hours have passed. So if the first one is traveling at 10 miles per hour and 2 hours have passed, that means that they have traveled 20 miles. So this is B1. And ship 2, B2, boat 2, is traveling at 12 miles per hour. So this is 24 miles. So what we want to know is how far apart they are. So this. So I'm going to call this, just to keep to the letters A, B, C, I'm going to call this little a. And I'm going to call 20 little b, and I'm going to call 24 little c. So I'm working with this triangle here. Now, if I know that I have 38 degrees and 47 degrees, the north-south line makes a straight line, which means that that's 180 degrees. Which means that I can find this angle right here. Because all 3 of them are going to add up to 180. So this is going to be angle A. That doesn't look like an A at all. Let's make it a little bigger. So angle A is going to equal to 180 degrees minus 38 minus 47. Because again, it makes a supplementary angle together. So A is going to be 95 degrees. So what do I have? I have big A, little b, and little c. So 2 sides, 1 angle that's not matching. I am in case 3. So I'm going to use the law of cosines, and I'm going to solve for little a by using the law of cosines. So I have a squared. Actually, let me write the formula here first. A squared is equal to b squared plus c squared minus 2bc cosine of a. So let's plug in. A squared is equal to 20 squared plus 24 squared minus 2 times 20 times 24 cosine of 95 degrees. And without a calculator, I don't expect you to start squaring these large numbers. You don't need to worry about that. So we're just going to square root. So we're going to have 20 squared plus 24 squared times 2 times 20 times 24 cosine of 95 degrees. And we are in, this is important because it's an application, miles. So here's my calculator ready answer. So this is how far apart they are. And if you wanted to know the exact number, you would plug that into your calculator, probably round to the nearest 10th or 100th. Okay, let's do another one. A chandelier is suspended from the ceiling by 2 chains. One chain is 46 centimeters long and forms a 60-degree angle with the ceiling. The other chain is 64 centimeters long. Okay, so the one is longer than the other. So you have a chandelier, it's hanging from the ceiling, which makes sense. That's a terrible line. Let's try that again. Better. So we have that one here is a little bit longer, and one of them is a little bit shorter. And so the shorter one, the 46 centimeter one, creates a 60-degree angle with the ceiling. This is 46, this is 64, and so we want to know here what this is. So I'm going to call this little a, which would make this big A, and I'm going to call this little b, which would make this big B. So I have little a, little b, big A. So I am in case 2, the ambiguous case. But because it's an application and they told you the diagram, the situation here, you definitely have one triangle. So I can use the law of sines to solve for, oh, sorry, I don't have big A, I had big B, still case 2. I'm going to solve for angle A. So I have the sine of A over 46 is equal to the sine of 60 degrees over 64. I'm going to bring 46 over, and then I'm going to sine inverse. So I'm going to take this in 2 steps. I'm also going to change the sine of 60 to radical 3 over 2 over 64. So I have A is equal to sine inverse. 46 divided by 2 is 23 square root of 3 over 64. And there it is. Here's my calculator ready answer. So this would be the angle that the longer chain makes with the ceiling. Let's do another one. To approximate the length of the lake, a surveyor starts at one end of the lake and walks 245 yards. He then turns 110 degrees and walks 270 yards until he arrives at the other end of the lake. Approximately how long is the lake? So we definitely have a lake. So we have a lake, and one end of the lake to the other end of the lake. So he starts at one end. I'll start on the left, but the diagram would look the same. And he starts to walk 245 yards. He then turns and walks 270 yards. Not drawn to scale because my 245 looks a little bit bigger than my 270. And we want to know from there, how long is the lake? Now, the tricky part here, and something that I've seen people make mistake, is where do they place the 110? So many people would place it here. And so that's incorrect. Because remember that he's walking, imagine him walking from the left the 245 yards. Imagine that's a trail. If he was to continue to go straight, he would continue this way. So when he turns his body, because when you do 110 degrees, you're looking at the front of your body. This is 110 degrees here, not on the inside of the triangle. However, that makes a straight line, so I can find the inside of the triangle by subtracting it by 180, so this is going to be 70 degrees. So I'm going to assign some letters. I'm going to call this little a. I'm going to call this little b, so this would be angle C. So I have little a, little b, big C. So I am in case 3, which means I need to use the law of cosines. So I'm looking for little c. So I have c squared is equal to a squared plus b squared minus 2ab cosine of c. C squared is equal to 245 degrees. I'm sorry, 245 squared plus 270 squared. Did not mean to put a degree symbol here. I really want it to be a degree. Minus 2 times 245 times 270 cosine of 70 degrees, which means that C is going to be the square root of all of this underneath. And I am an application, so I need to write my unit of measure, so it is yards. So here's my calculator ready form. Just to save time, you could bring that down. And again, I don't expect you without a calculator to start squaring this very large number. So I feel like the only really tricky part about this is placing the 110 degrees in the right place. Number 4. The distance on the map from an airport in Miami, Florida to the one in Nassau, Bahamas is 295 kilometers due east. Bangor, Maine is northeast of both cities. Its airport is 2,350 kilometers from Miami and 2,323 kilometers from Nassau. What bearing would a plane need to fly from Nassau to Bangor? Okay, so we have Miami, Florida here. And then east is Nassau. I don't think that it's actually directly east, but I guess they're doing an approximation here. It's very close to being east, but not directly, I think. But maybe it is. So Maine is northeast of both cities. That is definitely true. So this is going to be Maine. So northeast would be here. So we know that from Miami to the Bahamas, Nassau, Bahamas, is 295. From Miami to Maine, it's 2,350 kilometers. And from Nassau to Maine is 2,323 kilometers. And so we're looking at the bearing from Nassau to Bangor. So here, we're trying to go from here to here. So to have a bearing, I'm definitely going to have to draw a compass. So this is going to be north, this is going to be east, this is going to be south, and this is going to be west. We definitely know that the bearing is going to be northeast. That we already know. But we need to find out the angle. So the angle is going to be this angle right here. This is going to be the bearing. Now, if I look at the triangle I have, I can't find, using that triangle, I can't directly just find that angle. What I can do is find this angle here, which would be opposite of 2,350. And then I know that this is a 90-degree angle, so I can find the big angle and subtract 90 degrees from it. So let's create some letters. So I'm going to call this little a, little b, little c. And that means I'm looking for, at first, for big A. So if I have little a, little b, little c, I am in case 4. When I have 3 sides, which means that I need to use the law of cosines. So I'm going to solve for a by using a squared is equal to b squared plus c squared minus 2bc cosine of a. So now I'm going to plug in. So I have 2,350 squared is equal to 295 squared plus 2,323 squared minus 2 times 295 times 2323 times the cosine of a. So I need to bring both of these over by subtracting them. So I have 2350 squared minus 295 squared minus 2323 squared is equal to negative 2. Just got to be careful with your algebra here. And then I'm going to divide by this to both sides. So when I do that, I'm going to have negative 2. 295 times 2323. So that's gone from this side. And then the final thing I'm going to do is cosine inverse. So it's going to be cosine inverse all of this. So I'm going to write it one more time for good measure. 2350 squared minus 295 squared minus 2323 squared. Be careful with your signs. Negative 2 times 295 times 2323. Okay, so that's A. That's the big blue one. But remember, I'm not looking for all of A. I'm only looking for the purple part. So if I actually do this in a different color. Oh, I did not mean to do that. So the big blue is A. This is what I just found. And then this part right here is 90 degrees. So the blue is the green and the purple together. So the green is 90 degrees. So if I want to find the purple, which I'll call theta, then I have that theta is equal to A minus the 90 degrees. So I'm taking the big blue and subtracting the green part because I don't want the green, I just want the purple. So my bearing is now going to be north, theta, east. And here's my final answer. So this is the bearing that the plane would have to go. So first I would find A, I would subtract 90 degrees from it, and that would be the angle that is going northeast. Okay, one more. To measure the height of a mountain, a surveyor takes two sightings of the peak of the mountain. The two sightings are 900 meters apart, and the angle of elevation from the first sighting to the peak is 47, while the second has an angle of elevation of 35 degrees. What is the height of the mountain? Okay, so we have a mountain, and we're looking at the peak here. Now, they take two sightings, 900 meters apart, which is not so far, so it has to be on the same side. Sighting 1, sighting 2. So you're taking the sightings to the peak. 1. Ooh, I can see already that. There we go. And then we have the height of the mountain, which is going to go always directly down. And then this would be, here we go. So this is the height. Now, how do I know where I'm going to place my angle of elevation? It doesn't tell me which one is which. It just tells me that one is 47 and one is 35. The way you're going to do that is actually because the closer you look, the closer you walk towards something, the higher you need to raise your head. And the angle of elevation is the movement that your head does from neutral, which is straight ahead, to whatever you're looking up to. So the closer you are, the higher you need to raise your head. So the closer sighting has the larger angle, so the 47 degrees. And this one has 35. So this is actually going to be a two-part question. Because what happens is that I have a right triangle, which I'm going to take on the side here, where this is H, and this is 47 degrees. But I have no idea what this side is or what this side is. So I can't use SOHCAHTOA. So what you're actually going to do is find the hypotenuse by using the other triangle that you have. And the other triangle that you have, let me see if I can make it a little bit smaller, is this triangle right here. This oblique triangle. So you are going to find the hypotenuse of the purple triangle, which is one of the sides of the oblique triangle. So I'm going to take this oblique triangle out. So this is 900. I'm going to actually make it a little bit bigger. That was a little... Oh, it's not happening for me. All right. There we go. Everything is better when the visual makes sense. Okay, so I know this is 35 degrees. I know on the outside here is 47. Now, because this makes a straight line, it means it's supplementary. So I can find the angle on the inside by subtracting 47, which would be 133. And then all three angles add up to 180. So this one is going to have to be 12 degrees. So remember that I'm looking for this, which I'm going to call X. So I'm looking for this so I can use the law of sines because I have all angles, and that's case 1. So I have the sine of 12 degrees over 900 is equal to the sine of 35 degrees over X. When I cross multiply and divide by sine of 12, I'll get 900 sine of 35 degrees over the sine of 12. Now I have my question mark. This was X at the top here. I found that. So what I can do next is, now that I have that X here, so this is my right triangle, this is H, this is 47, this is X, I can use SOHCAHTOA because I have opposite and I have hypotenuse. So I have the sine of 47 degrees is equal to opposite over hypotenuse, which means that the height is X sine of 47 degrees. And if I plug in X, I'm going to get 900 sine of 35 degrees times the sine of 47 degrees over the sine of 12 degrees. And I have an application, so I should write my unit of measure, and we were in meters. So here's my final calculator ready answer. And this is how high the mountain is. This is actually a very common way, especially back in the days, of measuring things that were too high to just, use a ruler. So mountains are one of those things that you obviously can't just go to the peak and roll down a measuring tape. So this is an actual method of how you measure things that were extremely tall.